In this question from AP Calculus Studies, they say that the edge of a cube was measured as 11 inches with a possible error in measurement of 0.2 inches. And they say use differentials to estimate the maximum possible error in the volume of the cube. And what is the percent relative error? So there are different types of errors, and propagation error or propagation of uncertainty is defined as the effect of a function by a variable's uncertainty. So it is a calculus-derived statistical calculation designed to combine uncertainties from multiple variables in order to provide an accurate measurement of uncertainty. So to calculate the propagated error, you would have the measurement of the function f of x and the difference between f of x and f of x plus delta x. And then for the relative error, if you measure x, then to calculate the relative error, you would have delta x over that measured x quantity. And then for the percent of the relative error, you would have this number, the one that when you calculate, you convert it into a percentage, so you can have the percentage representation of the error. So in this case, in order to calculate the relative error, I need delta L over L. So that is going to be my relative error. Then I'm going to write the volume of the cube. So the volume of the cube is equal L to the third, where L is the side of the cube. Then if I have dV over dL, I will get 3L squared. Then dV, if I calculate for dV alone, I have 3L squared dL. And then after this, since dV and delta V are the same things, so I can write dV as this expression. And then if I want to rewrite it as delta V, so if I want to rewrite it as delta V, I can write it as 3L squared and then delta L. Now, if I want to calculate the relative error for the volume, I would have delta V over V. So for the delta V, I have to calculate and plug in the numbers. For my delta V, I have 3 times L squared delta L divided by L cubed for the volume. I can cancel L squared from the top and the bottom, from numerator and denominator, and I'll have 3 delta L divided by L, which gives me 3 times 0.2 divided by 11. And I also can say positive, negative 0.2, so depending on which side the error was made. So delta V over V is equal to positive, negative 0.0545. And if I convert this into the percentage, which they ask the percent relative error, then I will get 5.45%.